تشوفون الشاشة شباب؟
ايه
طيب يا شباب بسم الله الرحمن الرحيم. Last time يا شباب we talked about the specific heat Cp and Cv as properties, okay, and then we also talked about some approximations for liquids and solids, and we said we can approximate liquids if we have a liquid or a state where is a compressed liquid phase. We can approximate it by the saturated liquid properties. Why? Because at the constant pressure line in a TV diagram, we see that these lines in the compressed liquid are actually quite close, sometimes to the, or most of the time they're close to the saturated liquid data. As compared to يا شباب البريشر PV diagram, okay? So maybe I did not mention this last time. Like if we plot PV diagram and we look at this here, we can see that for the constant temperature line, it will be something like this. Okay, so you can see here that يا شباب, if we have at a constant pressure, at different pressures, okay, you see the difference between these can be large, okay, as compared to the TV diagram. That's why here we cannot approximate the liquids at that pressure. No, we should approximate it by the saturated liquid properties at the given temperature, okay. And then we talked about also the incompressible model. Okay, we said for liquids and solids, we can approximate the substances to be a incompressible substance if the density or the specific volume is constant. And we know that the density is the reciprocal of the specific volume, okay? Or vice versa. So, which means that the properties in this case for incompressible model is a function of temperature only. And the implication is that we can rewrite the Cv and Cp. We can see that the Cv and Cp in this case are equal, okay, for incompressible substance. And then we can also calculate delta U and delta H from this specific heat, either for variable specific heat or for constant specific heat. Okay, so this is what we talked about last time. أي سؤال عليها? Any questions? طيب شباب, today before the quiz, I would like to talk about the properties for gases. Okay, properties for gases. Okay, and the first thing I would like to talk about here is what we call, okay, so it's an important factor or parameter, we call it universal gas constant. سمعتم فيه يا شباب هذا؟ Have you heard about the universal gas constant؟
اللي هو الار يا دكتور.
بالضبط, اللي هو
8.413 او شيء زي كذا او 314.
صحيح, اللي هو 8.314. طيب وش هو اليونيفرسال gas constant؟ Okay, let me explain to you, and please focus with me here يا شباب, trying to explain for the explanation of this universal gas constant. Okay, if you heard يا شباب, in physics, okay, in physics there are a few numbers they call them natural constants. Okay, يعني احنا سبحان الله في الحياة هذه في numbers in science and in physics we see that these numbers are fixed or they are constant. Okay, one of them is this universal gas constant. Let me try to explain to you what is this universal gas constant. The scientists came and tried to do one thing. Okay, they took, for example, here we have, let's say we have this piston cylinder device, okay. Let me put it here, okay. تخيل يا شباب انه انا جيت وعندي البيستون سيلندر هذا، اوكي. And then I brought مثلا air. I put air here, okay. And then what I tried to do, I tried to change the pressure inside by moving this piston. معي يا شباب. So if I change this piston, what will change? The pressure will change, and what else يا شباب? Huh? What else?
The volume.
The volume will change, okay? The specific volume. طيب, for now يا شباب, let me use, I will use the molar bases. تذكرون يا شباب الماس bases والmolar bases. So I will use here in this case the molar bases. So I will use this bar above my specific volume. So basically what I'm trying to do now, I brought air, I put it here, I fixed the temperature. شباب, this is important. So I tried to fix the temperature of air, and while fixing the temperature of air, what am I changing? I'm changing the pressure and the specific volume. I'm changing the pressure and the specific volume. فتخيل انه مثلا I tried to expand here, I moved this piston up, so maybe the temperature is trying to reduce, I'm trying to keep this constant by heating the piston cylinder. So the idea is يا شباب, the idea is keeping the temperature of air constant while changing the pressure and the specific volume. Is this clear? Is this clear what I'm trying to do here? طيب. And then they tried to plot this. قالوا خلونا نرسم طيب a relationship, okay, when I have this. So what they were trying to plot, they said, okay, let us plot P times volume over temperature, okay. قالوا خلونا نرسم هذا نحط في الواي axis this combination of terms, the pressure times the molar basis of the specific volume divided by the temperature versus the pressure, okay. So they try to plot PV over T versus P, or the pressure. What did they find? They found that the relationship, let's say for this air at T1, assume يا شباب انه الحين I'm doing this at one temperature, T1. Okay? So when they tried to plot this, they found it something, let's say, for example, something like this, some linear line. Okay? So the PV over T versus P came out to be this constant, or this linear line, linear relationship. Okay? قالوا طيب يا شباب, قالوا طيب خلونا نغير ال temperature, let's do it at another temperature, let's call it T2. Okay, so they changed the temperature of air, they fixed it at a different temperature, and then they repeated the experiment, and then they measured PV and T, and then they plotted PV over T versus P. They found maybe the relationship something like this. Okay, so they repeated it with different temperature. When they did that, they saw something maybe like this, T4 and so on. Okay, so something came to be some linear relationships. Whenever they changed the temperature, they found some linear relationship between P over T and between P. إلى الآن واضح يا شباب؟ إلى الآن واضح؟ Is it clear?
Yes, doctor.
Okay.
Yes, doctor.
طبعا when they did the experiment, يعني they have a minimum limit for the pressure, so they cannot go below a certain pressure, and this is, let's call it, this is zero absolute pressure. Okay, let's say this is zero absolute pressure. So they stopped at certain limit. They said after they did all of this, they said, okay, let us extrapolate. تذكرون يا شباب extrapolation? Let us extrapolate or extend these lines. When they try to do this, let me maybe change here. When they try to do this, they found that all lines, they extend to the same value. Wow, معقولة? Yes, يعني all the lines, they extended to the same value. الصدمة وين؟ الصدمة when they change air to, let's say, methane, the same thing, the same extended value was reached. Okay, they changed methane to water vapor and they repeated the experiment. They also got the same, they reached the same, this value of the PV over T. And then they said, okay, since this is something amazing, yani, this is something natural, okay, let's call this the universal gas constant. Okay, so if we want to write it mathematically, ya shabab, so we can write the limit where P goes to 0 of PV over T. They found that the limit of this goes to R bar, in this case bar, which is the molar basis, and then they call this is now the universal, this is basically the universal gas constant, and they found, ya shabab, this value is the same for all gases to be 8.314 kilojoule per kilomole Kelvin. Okay, and this is, ya shabab, basically the universal gas constant. أي سؤال عليها يا شباب؟ وضح وش الuniversal gas constant and how did they came up with it, or they يعني extracted this natural constant.
Yes, it's clear, Doctor.
All good. أي
Yeah.
سؤال؟ questions. بتخيلوا يا شباب انه في اليونيفرس ولا في النيتشر في constants كذا يعني natural. okay, no one knows سبحان الله يعني what's why these values, but they exist in nature. okay, this is one of them, the universal gas constant. طبعا
طبعا دكتور، عندي سؤال بس.
ايه تفضل.
هذا مو ب SI unit صح؟ اللي هو ال 8.314.
لا، هذا يعتبر اس اي، يعتبر اس اي لانه نتكلم
يعتبر
عن
كيلو جول؟
جول مور كلفن. this is اس اي.
اوكي، ثانك يو.
اوكي، طبعا بنتكلم عنها هذه. let me talk about it here. So the universal gas constant, as I said, this is in terms of mole. If I change this per kilogram of the substance, يعني if I change the mole to the kilogram, what can I use? What is the conversion factor I can use, يا شباب, if you remember, in this case? How can I change the mole to kilograms?
افوكادرو.
مو افوكادرو، لا، اللي هو المولر ويت حق الغاز نفسه. يعني if I have, let's say, H2O, it has some molecular weight. okay, والmolecular weight عبارة عن ايش؟ كيلو جول kilogram per kilomole. okay, so this is kind of the conversion factor. So if I use the molar basis of any gas, in this case, what is this? It's not universal gas constant anymore. We call it the specific gas constant. So R بدون البار اللي فوق عبارة عن R bar divided by M here. Let's call it M bar, and M bar is basically what? This is the molar mass. Okay. kilogram per kilo mole. So if I divide my R bar by M, which is the molar mass, I get what I call, this is now the specific gas constant. وش معناته؟ معناته this is specific to the gas itself, يعني to the type of the gas. معناته for each gas I will have different R. For each gas I have different R. لكن R bar applies for all gases. So it is universal for all gases. لكن the specific gas constant is for each type of gas. So air has R. مثلا water vapor has a different R. And so on. Okay? So this is the other important information in this case. Okay? أي سؤال عليها هذه؟ So we talked about the universal gas constant and then the specific gas constant, which you can get from the universal gas constant if you're talking about the kilogram of certain substance. Okay. Then يا شباب, the second property I wanted to talk about, or parameter, is what's called the compressibility factor, okay, which we call Z. So what is this compressibility factor? If we go back to the limit equation, okay, the equation for the limit, all right. So we said the limit of P goes to 0, okay, for PV over T is equal to R, okay. In this case, يا شباب, what I can do, if I take R to the other side, so it will be the limit P goes to 0, PV over R prime T. This is equals to what يا شباب؟ equal to what?
To 0.
ليش 0؟
N
هنا I divided by R هنا both sides.
حتكون
1.
1. Yes.
Okay, it's gonna equal to 1. Okay, so they said this combination of term here, let's call it Z, or yeah, let's call it Z, which is the compressibility factor. That's why Z is equal to PV over RT. Okay, PV over RT. This is what we call the compressibility factor. This is in terms of molar basis, and we can also rewrite it in terms of mass basis, which is PV over RT, and R here in this case. This is not the universal anymore. This is the specific gas constant. Okay. طيب, let us plot this Z. Okay. Remember, a limit حق Z goes to 1 as P goes to 0. Yes, so as the P goes to 0, the Z tends to be equal to 1. Okay, so let us see how this Z looks like. Okay, so in the x-axis here, I will have the pressure, okay, and Z is gonna be on the y-axis. This is the value for Z, which is 1. Okay, so as the P goes to 0, okay, this Z, okay, goes to 1. So they tried now, let's say they took a substance, let's say for example air, and they tried to plot this at different temperatures. Okay, so some of the trends for this temperature is the following. So the Z could be something like this. Let's say at 35 Kelvin, for example. Then they try to increase the temperature, let's say maybe 50 Kelvin. Okay, so it's something maybe like this. Okay, this is maybe 50 Kelvin. This is something like maybe 60 Kelvin. Okay, you have something also like this. Let's say this is 100 Kelvin. This is maybe 200 Kelvin. Okay, so the idea is يا شباب إنه there are certain trends for Z versus the pressure. Okay, however the idea is as the pressure goes to zero, this value gets closer to what? Gets closer to 1. Okay,
1.
and this is 1. So this is the idea you should understand. So that means as if we have application where the pressure is getting smaller every time, or the pressure is small, okay, and the Z is close to 1, all right. So let's actually write this down. So for small p, okay, Z tends to equal to 1. Okay, for small p, Z is getting closer to 1. طيب إذا صار Z is close to 1, what's the result يا شباب? Let's go back to this relationship. Remember يا شباب, now this is an equation relating what? Relating the properties for the gases. Okay, so this compressibility factor relates properties for the gases. It relates the pressure, the solid volume, the temperature, and the gas constant, and the Z. So this is a relationship between the properties for the gases. For a small p, Z tends to 1. So if we put Z equal to 1, وش الريزلت حقنا يا شباب? This equals to 1, which means PV equals RT. And what do we call this يا شباب? We call this the ideal
gas.
gas
equation or model, the ideal gas model. فلما تسمعون يا شباب ideal gas, لما تقولون this gas is ideal, it means our Z is close to 1. We assume it is closer to 1. Okay, or we do experiments, or we do calculation and check, okay, and see that Z is close to 1, then I can say, okay, I can assume this is ideal gas model. I will put Z equals to 1, and then I will use PV equals RT. So the ideal gas model gives you a relationship between the gas's properties, okay, where the compressibility factor equals to 1. Okay, وضحت يا شباب؟ وضحت هنا؟
Yes, Victor.
Yes.
Is this clear؟
Yes.
معقولة ما في أسئلة يعني للدرجة دي؟ ما شاء الله عليه، يعني خطير.
لسه ما جت الأسئلة، يعني ما دخلنا
اسأل
سهل شوي.
بليز يعني.
طيب يا دكتور، لو كان أقل من 1، لو كان مثلا Z يساوي 0.5.
الزي the minimum is قصدك الزي أقل من 1؟
ايوه.
عادي يصير أقل من 1. أصلا لو تشوف هنا احنا ما نتكلم على الزي، نتكلم، شوف الزي هذا can be here. You can see these values here are below 1 وفي values above 1. اوكي، مو كلامنا هذا، كلامنا انه it is close to 1 يعني
when the P is 0.
when the P is 0. يعني احنا نتكلم عن ال P هنا. If the P is getting smaller as it goes to 0, ال Z هنا is getting close to this
One.
value 1. Okay, it could be below 1 as Z, it could be above than 1, more than 1, it's fine. And as the P goes to 0, the Z tends to go to 1.
Yeah.
Yeah. More questions? وقاعدين تفكرون في الكويز. Any questions?
ايوه
شباب, this is important. يعني التوبيك هذا is very very important. It's very important. يعني definitely you will see second homework will be on this topic, يعني on the gases and compressibility factor. Okay. طيب ممتاز. Any questions? Any other questions? Yes.
دكتور عندي سؤال بخصوص الميد تيرم، هل في أي أخبار عن الموعد؟
Let's delay this. I don't want to waste time for on this question now.
بس في الكونسبت اللي شرحته قبل شوي.
Hey. Yes.
الكمبرسبيليتي فاكتور انا فهمت الماثيماتيكال يعني شو اسمه الشرح الرياضي يعني، لكن كونسبشوال يعني اذا زاد الكمبرسبيليتي فاكتور ايش يصير في الغاز من ناحيه كونسبشوال يعني؟
conceptual من الاسم وش يعني compressible، يعني كانه يعني بيكون بيصير خلينا نقول في effect there's compressibility effect. اوكي
يعني يصير يسهل ضغطه،
يعني يصير انه كانه highly compressed. فهمت؟
كل ما زاد كل ما صار هاي كومبريست.
ايوه من البريشر احنا وش قلنا as the pressure goes to 0 ال Z tends to 1، لكن if the pressure is high ال Z it will be very far from 1. that means there is compressibility effect، يعني الضغط اللي يعني الضغط الحاصل is highly affecting the pressure and the properties اللي هو affecting the volume affecting the temperature. فهمت قصدي؟ فإتس relates، يعني يوم حطينا Z to 1 وش طلع لنا relationship between the PV and RT. اوكي؟ لكن لما يكون عندي Z far from 1 it will start influencing this relationship. كأنه it adds a compressibility effect on the gas.
اي نعم وضحت دكتور.
Very good question by the way. طبعا برضو الايكويشن هذه ال PV equal RT، او خلينا نقول any equation that relates properties for gases like this we call it يا شباب ايش؟ equation of state. So this is ideal gas model or ideal gas
equation state.
Yes, equation of state. Okay, but يعني remember this equation of state, it's an equation that relates the properties for gases. The last point I want to make before going to the quiz which will start in 3 or 4 minutes is the following. الحين يا شباب هنا لو ناخذ أي gas, let's say this is air, if we change the air خلينا نقول water vapor, الchart هذا will change. Okay, this chart will be different. But they tried to generalize a chart. Okay, they tried to use a general chart that can be applied for all gases. How can we do this? Usually, okay, if we want to generalize any problem, okay, we do normalization. We do normalization. What do you mean by normalization? معناته a temperature, instead of plotting temperature, I will plot temperature divided by some certain value. Okay, and in this case يا شباب they said okay, let me not plot the temperature and pressure and volume, let us plot what we call reduced temperature, TR. What about the pressure? Okay, I will divide the pressure by the critical pressure. هنا I divide the temperature by ايش? By the critical temperature. البريشر I divide it by the critical pressure. Okay, so they said let us plot Z not as a function of pressure and temperature. Let's plot it as a function of critical pressure and critical temperature, and also maybe critical specific volume. Critical specific volume is not going to be straightforward like this. I will show you its equation later. Okay, but the idea وين يا شباب؟ الidea انه قالوا بدال ما نرسم chart، بدال ما نرسم Z versus P and for different T، remember these are T lines T1 T2، قالوا بدال ما نرسم هذه خلينا نرسم Z versus P reduced اللي هو P over P critical and T over T critical. الشيء العجيب وين يا شباب؟ الشيء العجيب انه when they did this for multiple gases and multiple temperatures and pressures, they found these lines are the same. They found the same trends, the same value for the Z. وضحت الفكرة؟ So when they did this for multiple gases, for multiple temperature and pressures, when they normalized the temperature and pressure by the critical temperature and critical pressure, the Z was the same for all, يعني for a good number of gases, for air, for water vapor, for methane, for ammonia, for blah blah blah. They changed the gases when they normalized each temperature by its corresponding critical pressure and critical temperature, the Z was the same. Okay, so that's why they said, okay, this is something really amazing and it's important. So let's call this the generalized compressibility chart. So this is generalized compressibility chart. And next time, Shabab, I will show you the compressibility chart again, and I'll explain this, inshallah, better. Okay? So, any question here? Any question? Any question? طيب يا شباب, الquiz I think already started. It has 4 questions. يعني one زي matching, يعني you'll see a graph and then you match. It's a matching question, and then you have input entering the final answer, يعني like a blank, and then you write the final answer based on the tables. يعني you need to use the table in order to answer this question. Okay, so go ahead يا شباب, make sure you have good connection and refresh your blackboard before you start the quiz. You find it under assessment.
No cameras, doctor?
Huh?
No cameras.
That's fine. No cameras for now because I'm using Blackboard as an input, يعني numerical input. Okay? So you don't have to scan. You don't have to do that. It's through the Blackboard. Okay? So go ahead يا شباب and start the quiz.